Right, good day, grade 10s. We are carrying on with complex numbers today. You should have printed out the worksheet for video session 7, simplification of complex numbers. We are very lucky today to have 3 people who have come into the studio to help make this video and to help us with the answers. We have Neo, hello Neo, and we have her neighbor, Ishani. Hello, Ishani. And then just behind them, okay, is Georgia. Oh, Georgia. Right, so I'm very grateful for them to risking their liberties and freedom by breaking lockdown to help us out with this worksheet. So you'll be completing the worksheet while we are working through it. You have a wonderful pause button, which you're welcome to use. Right. Let us switch share, sorry, and we're sharing over here, and that is that. Right, and let us begin with the worksheet. So we discussed the other day complex numbers. Remember that the square root of -1 didn't exist, so we made it up, and it is called I. Okay, and follows from that I squared is equal to -1. So what we're doing today is simplification of complex numbers, and we're also later on going to do conjugates of those numbers. Right. So your process for multiplying out is very similar just to your normal algebra techniques. Okay, so you've got I times 7i minus 2 squared. So to do that, your normal rules apply. So you're going to have to use this logic that a minus b squared, you should know the shortcut by now, is a squared times them together times by 2, so minus 2ab plus b squared. So that is the principle we're going to use, and you're going to do your squaring first and then multiply by I. So this becomes I times, well, 7 squared is going to be, I'm not going to simplify it yet, with practice you'll get used to it. So Ishani, do this with me. So it's going to be, I can hear her, I'm afraid you can't hear her in the studio, so she's just helping me out here. 49i squared times them together, it's going to be minus 14i times 2 is minus 28i. So when 7i times 2 is 14i times by negative, 7i times -2 is negative 14i, times by 2 is negative 28i, and then -2 squared is plus 4. So 49, I'm just following that pattern, 49i squared minus 14i times 2 minus 28i plus 4. Now we've got to distribute that I throughout the whole bracket. So it becomes, okay, I'm going to do something before that though. Okay, we can distribute now, it'll work out, I'll do it both ways. Okay, but what will probably make our lives a lot easier is to simplify the bracket first. And the key idea, remember, is that I squared is equal to -1. And with practice, you're just going to go 7i all squared is 49i squared, which is 49 times -1, which is -49. Okay, so I squared is -1. I'm just replacing I squared with -1. So I get 49 times -1. So this is one way you can do it. I squared is -1. So it's times by 49 is -49 minus 28i plus 4. And we can simplify that further if you want. And you get I minus 49 plus 4 is minus 45 and minus 28i. And if you distribute the I now, you get -45i minus 28i squared, which simplifies to minus 45i, but then I squared is -1, right? So -28 times -1 is plus 28, and there is the final answer, -45i plus 28. Okay, remember I squared is -1. The alternate way you could have done the sum is, instead of simplifying the bracket first, is you could have times I in to the bracket. So then it'll become 49, and I would suspect this is going to be a little bit more complex, I cubed. Okay, so I get 49i cubed. Yeah, it's going to be a pain in the bum. Okay, minus 28i squared, but let's just go with it. Okay, so say you did this plus 4i. Right, then you kind of have to work backwards, because I cubed, remember when we did this the other day, if you've got an odd number, you've got to change it to an even. So I can rewrite I cubed, I'm kind of going backwards a bit. That's 49i times I squared. Okay. Okay, if I do that, negative 49i, I just rewritten I cubed as I times I squared. Okay. Then minus 28, and then I've got I squared, which I can write as negative 1, that's I squared, okay, plus 4i. So now, if I carry on here, I squared is negative 1, so 49i times negative 1 is going to be negative 49i, minus 28 times minus 1 is going to be plus 28, plus 4i. If I add like terms now, negative 49i plus 4i is minus 45i plus 28, okay, which is the same answer as what I got when I did it the other way. So those two different methods produced the same answer, negative 45i plus 28. Okay, remember, if you've got an odd power, I always just do it by writing it as I times an even, okay, and then I work from there. Okay, right, let's have a look at example 2. So you've got 3 plus 4i times 5 minus 2i minus I squared times I to the 5 minus 1. Well, the first thing you're going to do is apply FOIL here. So Georgia, if I apply FOIL, okay, what do we get? Okay, you're going to get 15, okay, minus 6i. Hopefully, Georgia, you've been listening to some Blink 182, plus 20i. If you haven't, you should just get the greatest hits to start off with. Minus 8i squared. Okay, so that is that multiplied out. Okay, 15 minus 6i plus 20i minus 8i. Ooh, nearly a mistake. 8i squared. Any mistakes? I'll do push-ups. I would straight away change I squared to negative 1. It's just going to make your life easier. So I'm going to go minus, I change this I squared into negative 1. So it becomes minus minus 1 times I to, you don't have to though. I mean, you could just distribute it perfectly fine, but I'm not going to show you both ways. I to the 5 minus I. So all I've done is change that I squared into negative 1. Right, let's start making this a bit prettier. Okay, so we're going to get, with practice, you're going to skip out quite a few of these steps. Minus 6i plus 20i is going to be 14i. Just adding those two. I squared is negative 1. So negative 8 times negative 1 is plus 8. Okay. Then I've got 1 times I to the 5, because negative times a negative makes positive 1. 1 times I to the 5 is I to the 5. Okay. And then I've got 1 times negative I, which is negative I. Right. If we make this prettier, let's start adding up like terms. 15 plus 8 gives us 23. 14i minus I is plus 13i. And then we've got to deal with this I to the 5. So you can write it as I times, there's all kinds of ways you can do this, but this is how I normally do it. I times I to the 4. Okay. And then I to the 4, I'm just going to go and do this little part over here. Okay. Remember, I to the 4 means, the way I can work out I to the 4 is it's I squared all squared, which is negative 1 squared, which is 1. Okay, so I to the 4, I squared all squared, negative 1 squared is 1, so I to the 4 basically becomes 1. Okay, so I end up with 23 plus 13i plus I times, well, I to the 4 is 1, so it's just plus I, and I end up with 14i plus 23. Okay, first one to spot any deliberate errors. Okay, please let me know. You'll win a prize. Okay, you'll get to spend a week with, let me just focus this a bit. a week with Kyra. Second prize is 2 weeks with Kyra. Right, okay, so that is question number 1. Question, page 2. Okay, and there's a little note here. Right, and it says, any complex number can be written in the form Z is equal to A plus BI. That's just the common notation that we use. Okay, we give a complex number a name. It could be Z, it could be X, could be Y, but it basically consists, what we're going to do is we're going to call this is going to be referred to as the real part of the complex number, and this bit over here is going to be called the imaginary part of the complex number. So A, we'll see now, is going to be called the real part, and B, the coefficient of I, is the imaginary part. Okay, but any complex number is made up of a real part and an imaginary part. Okay, the real part could be 0, the imaginary part could be 0. Okay, so the real part of Z, for Z is equal to A plus BI. So the real part of Z, if Z is A plus BI, is A. Okay, and that is called, and that is basically the term without I. Okay, and we say that the notation we use is that the real part of Z is equal to A. The imaginary part of Z, imaginary part of Z for Z is equal to A plus BI. So that, but B is the imaginary part of F, in other words, of Z, the coefficient, okay, of I. It's a number in front of I, and we say that the imaginary part of Z is equal to B, just that coefficient. Okay. So in example 3, we're given a complex number, Z is equal to 4 minus 7i. If they say to you, the question says find the imaginary part of Z, okay, I should really just, the instruction could have just been write down. And the imaginary part of Z is simply the coefficient of I, which is negative 7. That's the imaginary part of Z. And then the real part of Z, okay, is that bit over there, the term without I in it. So the real part of Z is equal to 4. Easy peasy, lemon squeezy. Thank you, Janeo, for bossing me in the background and for telling me what to do. I couldn't have done it without you, Janeo. Right. Now, let's have a look. Okay, so, Shani. Just some notation that we're going to use. Okay. It says, given x is equal to 3 minus 2i and y is equal to 5 plus 3i. So x is a complex number and y is a complex number. The question says determine the real part of x plus y. So now that's an instruction. It means go find the real part of x plus y. So to do this, we haven't found the real part yet. X is equal to, replace x with 3 minus 2i plus y. Okay, so it's going to be plus 5 plus 3i. So I'm looking for the real part of that. So go simplify it. So I'm looking for the real part of 3 plus 5 is 8. Minus 2i plus 3i is I. So Ishani, what's the real part going to be? Well, the real part of 8 plus I is simply 8. So there's your final answer. The real part of x plus y is 8. So you've always got to first simplify things and then look for the real or imaginary part. Right, so Georgia, the imaginary part of x times y. So we're looking for the imaginary part of 3 minus 2i, that's x, times y, which is 5 plus 3i. Just go use FOIL, and we get the imaginary part of 15, okay, plus 9i, you can skip out steps, minus 10i, I'm just using FOIL, minus 6i squared. Okay. With practice, minus 6i squared, you're just going to write as plus 6y, because I squared is negative 1. Remember, okay, I squared is equal to negative 1. So I'm looking for the imaginary part of, well, I'm just going to skip out a step. Minus 6i squared becomes minus 6 times minus 1, which is plus 6. So this whole thing over here is plus 6. Okay, that whole term over here is plus 6. So I end up with the imaginary, I'm looking for the imaginary part of 15 plus 6 is 21. And then 9i minus 10i is negative I. So what's the imaginary part of that? Well, what's the coefficient of negative I? It's negative 1. And there is your answer. Your imaginary part of xy is equal to negative 1. Right. The next thing we're dealing with is complex conjugates. And again, don't forget your key idea. I squared is negative 1. So if I squared is negative 1, in other words, the square root of negative 1 is equal to I. So I is just not a random variable. It is an imaginary number. That's what they're actually saying here. Okay, so in that scenario over there, okay, it says, given z is equal to a plus bi, where I squared is equal to negative 1, then the complex conjugate of z, and the notation we use for that is z star. So z star is the notation we use for the complex conjugate. Conjugate means opposite. Go look up what conjugal rights in prison means. Okay, called z, in the complex conjugate of z, called z star, is equal to a minus bi. And what you simply do, okay, is you go to the imaginary part of the complex number and you change the sign of the coefficient. So b has changed to negative b. That's what a complex conjugate is, and it's going to have some important uses later on. Okay, so you need to know that definition. What is a complex conjugate of a complex number? Well, you just change the sign of the imaginary term. So given x is equal to 3 minus 2i, go write down x star. And x, how do I read x star? I read it as the conjugate of x. So what's the conjugate of x going to be? Okay, let's have Nao. What's the conjugate of x? Oh, Nao, pay attention, you are wrong. It is 3 plus 2i. Okay, all you do is you change the sign of the imaginary part of the complex number. And then, Shani, if y is 3 plus 5, y is equal to 5 plus 3i, what is going to be the conjugate? Done, Shani. 5 minus 3i. All you're doing is changing the sign, easy peasy, of the imaginary part. And then, Georgia, if I have z is equal to negative I plus 4, be careful. Okay, the imaginary part changes signs. So negative I will become positive I, okay, and 4 will stay the same. Okay, so it's the sign of the imaginary part which changes. Okay, all right. So that's page 3, done. Okay, righty then. Last page, page 4. Okay, and in this example, I've taken it straight from exercise 3 of your Mind-Born Maths on page 5. Okay, and we're doing question B4. And the question says, given x is equal to 1 minus 2i and y is equal to 2 plus I, evaluate in the form a plus bi. So that's the question. Evaluate in the form a plus bi the conjugate of x squared minus the conjugate of y squared. Have I written that question down correctly? Just double checking it. Somehow it made me feel like I didn't. Conjugate of x squared minus the conjugate of y squared is indeed correct. Okay, so first of all, here's x. So Ishani, what's the conjugate of x? Indeed, it is 1 plus 2i. So I'm going to have 1 minus 2i is the original. If x is 1 minus 2i, then the conjugate of x is 1 plus 2i. So I'm looking for 1 plus 2i squared minus, now if y is 2 plus I, what's the conjugate of y? It's 2 minus I, and I've got to go square that out. Now if I do the simplification, remember using a plus b squared is equal to a squared plus 2ab plus b squared. Okay, so it's going to be 1 squared, which is 1, times them together, 2i times 2 is 4i, okay, plus 2i squared. And remember, 2i squared means 2i all squared is 4i squared, but I squared is negative 1, so it's 4 times negative 1, which is negative 4. Okay, so 2i all squared. 2i all squared is 4i squared, which is 4 times negative 1, which is negative 4. You need to start being able to do that in your head. 2 squared is 4, I squared is negative 1, so you get negative 4 minus using this pattern again. 2 squared is 4. Times them together times by 2. You're going to get minus 2i times 2 is minus 4i. And then you're going to get, when you square a negative, it becomes positive. So you get plus I squared, and I squared is negative 1. So if I neaten that up, I get 1 minus 4 is negative 3 plus 4i. And then over here, 4 minus 1 is 3. So I get negative 3. Okay, 4 minus 1 is 3. Times by negative is negative 3. Negative times negative 4i is plus 4i. So I end up with negative 6 plus 8i. And that is your answer to this question over here. Simplifies to negative 6 plus 8i. How amazingly was that? Right, for the remainder of the lesson, I want you to do, once you've completed your worksheet, Mind-Born Maths, Calculus and Algebra, your purple book, all of exercise 2 on page 4, and exercise 3, page 5, all of A and B, just 1, 2, and 3. Thank you to our special guests, okay, to Nail and to Shani. There's the Shani's eye, okay, and to Georgia, okay. Have a fantastic day, everyone. Arrivederci. Stay safe.